Back. So now continuing on the lecture slide for antiderivatives. You say capital F is an antiderivative of little f if its derivative is this. You understand? So antiderivative means goes back. Okay. For example, let's consider fx equals x squared. What is the antiderivative of this? Increase the power, divide by 3. Okay, divide by the new power. Why? If I take the derivative of this, the 3 will come down and cancel the 3 and I'll be left with x squared, which is what I want. Okay, so antiderivative does the opposite of what derivative did. Now notice if I add 100, that will also give me the same derivative because that's a constant. So both capital F and capital G are antiderivatives of f. Indeed, any function of the form hx equals 1/3 x power 3 plus a constant is an antiderivative, okay, of x squared. Check again. Take the derivative of hx. Well, the 3 comes down, cancels the 3, you have x squared. For c, you add 0. So, derivative of this is this, right? Therefore, antiderivative of this is this, where c can be any constant. All right? The following theorem says that f has no other antiderivative. If capital F is an antiderivative of little f, then the most general antiderivative of little f is capital F plus some constant, any arbitrary constant. So the antiderivative of x squared is 1/3 x cubed plus c, where c is any arbitrary constant. Okay. By assigning specific values to the constant c, we obtain a family of functions whose graphs are vertical translates of one another. So here you have x cube over 3. If I subtract 1, I drop 1 unit. If I subtract 2, I drop from here 2 places. If I add 1, I lift this 1 place above. Here I lift this 2 places above. Here I lift 3 places above, and so on. So they all have noticed the same slope. Yes, that is why they all have the same derivative. Adding a constant or subtracting a constant will not change their slope. Okay, so all of these functions have derivative x squared. Okay, find the most general antiderivative. So this is what it means to say most general. When you write plus c, it is most general. If you don't write plus c, say you erase it, then what you are left with is one kind. It's just one antiderivative. If I add 10, that is another antiderivative. If I add 100, that's another antiderivative. If I subtract 2000, that's another antiderivative. Instead, if I write plus c, it is called general antiderivative. Okay? So, question is, find the most general antiderivative of each of these guys. Well, let's see whose derivative is sine. Well, derivative of cosine is negative sine. So derivative of negative cosine is plus sine. Okay. So this is one antiderivative. But the question wants me to find general antiderivative. So I have to add constant. So negative cosine x plus c. This guy's derivative is sine. Okay. Likewise for b, let's go. Now consider x to the power n plus 1 over n plus 1, n being any number, so think 10 if you like, right? When I take derivative of this expression, this is simply a number, right? N plus 1, so that stays put. The exponent comes down and gets reduced by 1. Now this n plus 1 cancels the denominator, and that gives me x to the power n. Aha, that's very good. In other words, the antiderivative of x to the power 1 n is this guy. But I am asked for a general one, so I have to take that guy, add constant. This is the general antiderivative of x to the power n. Okay? This is valid for all n greater equals 0. Okay? So this is defined on our interval. Next. In general, suppose you put n equals negative 3. Well, negative 3 plus 1 is negative 2. Negative 3 plus 1 is negative 2. Okay. So, what is this? Negative x to the power negative 2 over negative 2. This is an antiderivative of x to the power negative 3. But they are not defined at x equals 0. All right. But you do need to add c. All right. So what happens here? To the right of 0, you can add one constant. To the left of 0, you could add some other constant. You are not required to add the same constant. All right. So, general antiderivative, you can add different constants on either side of 0 because my function was not defined at 0 anyway. Okay. 0 makes this undefined. Okay, so here is the table of anti-differentiation formulae. Okay, if I multiply by a c, that continues. If I add two functions, the antiderivatives continue. X to the power n antiderivative is increase and divide. I hope it's clear. Antiderivative is opposite of derivative. Derivative brings that down and decreases. Antiderivative increases and divide, right? Instead of multiplying, you're dividing. Antiderivative of cosine is sine. Antiderivative of sine is negative cosine. Secant squared is tan. Secant x tan x is secant x. Okay, antiderivatives. These are called particular antiderivatives because I have not added constant. If I add constant, that's when I get general antiderivatives. Okay, so I will stop this lesson here. I have only 2 more slides. No, I have a few more slides. I'll come back to this lesson. Okay, until then.